Hello, and I'm back. Yes, I was away for a little while, but I've got my voice back, which is something great. And today we're doing something new, a brand new series. It's going to be I'm going to try to make them as short as possible. And when I say as short as possible, around half an hour. I want to make them easily digestible. And because they are relatively advanced, I don't want to go too quick with it. This is the intermediate version of my popular ESPHome Basic setup for all devices, except that I'm not going to explain things line by line. For that, you can go there. And I will put a link up here. And in the description, you'll find the accompanying GitHub page for this tutorial. So what is this series going to be about? This series is called Coding Practices, Tips and Tricks. And it's specially designed for the intermediate ESPHome user who have already completed my tutorial on creating a room sensor from scratch up to today, and are looking to take their skills to a new level. Now, there are going to be more of those tutorials coming. However, understand that the upcoming tutorials that are part of this tutorial series are going to be code-related more than anything else. We won't need any devices to start with. In fact, the first three, including this one, does not require any device. Once we've demonstrated the functionality through coding, I will showcase on the device, and we will see the results in real time. If you want to jump ahead a little bit and want to see the entire process, you can go and have a look at the live stream that I did with Steve. It's about 2.5 hours, and we migrated the room sensor package and went into these techniques. One of the complaints that I got regarding that live stream is it wasn't in-depth enough, and certainly there were other issues around it, including the time. So in this tutorial, I'll be taking a more focused and structured approach to the coding practices to provide a deeper understanding of the concepts involved. If you're already familiar with YAML and ESPHome, these tutorials are designed to introduce you to more advanced methodologies to simplify your process. However, if you find that these tutorials are too complex at this stage for you, I recommend starting with my Creating a Room Sensor from Scratch series, which is perfect for the beginner, and it will help you to get you started. Once you have mastered the basic, you can return here to further explore ESPHome and all of its capabilities. If you have seen any of my previous tutorials, welcome back. I know that your time is valuable, so the tutorials has chapters which you can access on the video timeline or in the description. In this tutorial, as I explained, we will discuss modularizing the code and bringing some standard conventions that I use. But mostly I'll explain to you why. But let's get to the next section of this video. Some housekeeping and announcement before we start. I'd like to remind you that all of the scripts are on my GitHub page for this tutorial, and the links is in the description. If you have any questions, feel free to leave it in the comments below. I will try my best to answer you. If you think that there is a better way, feel free to voice your opinion as well. If you like this tutorial, please like, subscribe, and hit that notification bell, and maybe share it. This will enable the YouTube algorithm to present this tutorial to more people. But I think let's start. If you are here and this is an intermediate tutorial, I will assume that most or all of the software we will need for this tutorial and forthcoming ones you already have installed. But let's recap. We'll need Home Assistant. I recommend that to do these tutorials, you have a Home Assistant OS installed somewhere on a virtual machine or even on a physical machine if you can afford to do so. At least it wouldn't disrupt your main Home Assistant installation. Okay, we'll also need ESPHome, and the easiest way on Home Assistant operating system is to install the add-on. Now, I do have tutorials on installing the add-on for Home Assistant. The last piece of software we need is either Studio Code add-on. Again, I do have a tutorial for that. Or alternatively, Visual Studio Code Desktop. Now, if you are going to use Visual Code Desktop, you are going to need the Samba Share add-on. Again, I have tutorials on my channel to cover that. I will leave links to all of the tutorials on my GitHub page. There is a little issue with both Studio Code Server and Studio Code Desktop. I could never successfully compile directly from either. I don't even think that Studio Code Server has the ability to do so. And I do hope that these issues will get resolved in the future. Let me show you what happens when you try to compile from Studio Code Desktop. Let's jump over to my desktop. Here you can see our ESPHome sensor.yaml, and yes, it has changed name. I started using it full-time about 3 weeks ago when I introduced the PIR sensor. So I changed its name, and it lives both on the tutorial instance of Home Assistant and my main Home Assistant server. Okay, so this is it. There is nothing funny. The only thing that has changed since the last tutorial I did for the room sensor is that we are now using, and I'll scroll down a little bit, I just overshot it twice. We are now using an SHT40 instead of a DHT22. Okay, but that's the only change that there is in the code, and I will release a tutorial where I explain why I've changed it and where I compare some of the temperature and humidity sensors, particularly on the temperature side. You'd be amazed on the gap that there are. Anyway, over here, you will find a little button that says OTA. OTA is over the air update. And it actually says compile and upload over the air. I am going to click it, and it is going to start. And straight away, you can see it's going to say command no, not found, ESPHome. I keep having different issues here. I'm going to try again, and it's going to do exactly the same thing. Now you're going to say to me, yeah, but that sounds like an obvious one. You do not have the ESPHome tag or section inside of your code. I do. In fact, here it is. So that's not the problem. Furthermore, and let me show you, this is the web version or the web server version. As you can see, it doesn't even have the facility to compile and upload. So I am going to go to the ESPHome dashboard, and here it is. And just to show you that it compiles, and this is the same file. I'm going to open it, and you'll see it's the same file with the same changes. Let me find there is the SHT40. I'm just going to close it. And by the way, when we use this methodology, when we use Studio Code, the best way to compile is actually stay out of it. Click on these 3 dots over here and click on install. And we will do a wireless install as it is working, and it is from my point of view in production. And it's going to be pretty quick, and you can see no problem whatsoever. It's busy uploading it. I'm not going to bore us with the upload because I know it's up to date, so I'm going to cancel it. So unfortunately, throughout these tutorials, we're going to have to switch from one to the other. As I say, I hope that this will get resolved. So now that we've got that covered, let's get to why we are changing things now. Before I explain why we are changing things at this point in time, I'd like to just tell you that this specific video is going to be a lot of talking head. I am going to show some code, but it's going to be a lot of talking head. Let's get to it. So why are we changing things now? I think as we progress in using ESPHome, there is a point in time where the monolithic file no longer caters for our needs. And the biggest problem that I think that we have is that everything is in one single file and it's a mess. We try to find things and we can't. And we try to debug things and we've got hundreds and hundreds of lines. I mean, I have my basic setup is already nearly 200 lines. I've got files that are well over 700 lines and increasing in size all the time because I tweak this, I tweak that. It becomes very difficult to manage those files. It becomes more and more cumbersome and harder to decipher. With the code scattered across the entire file, because some of it is in the sensor section, some of it is in the binary sensor section, some of it is in the switch section. And each time that we add a new component, we have to add in the sensor section, and we have to add in this, and maybe we have to add a section of its own, or sorry, a component of its own. Typical one would be, and I don't have one under my hand, but the millimeter wave sensor is typical. It's got its own, plus it's got a whole lot of other things with it. In fact, it's well over 100 lines, if I remember well. So one way that we can resolve these problems is by modularizing our code. And I know it sounds daunting. I know it sounds, oh, this is very advanced. This is going to be difficult to do. In fact, it's not. Throughout this tutorial series, I am going to show you step by step how to do it and how to think about it. So it's not only going to be, this is what you do. It's going to be, this is why. And in fact, I would love if you end up adopting something that you've created yourself. Now, I'm going to show you my way of doing things. It's a framework. And as all framework, it has to be adapted to your needs. My needs were so, your needs are maybe different. Your wording is maybe different. This is why we are going to start by modularizing our code. And not only make it more manageable, but also increase its reusability. So the idea behind reusability is we do a sensor file or a sensor component once. And that is it. We don't touch it again, unless there are changes within ESPHome, and then we go and we fix it. Instead of scattering our sensors across hundreds of lines, now what we are doing is we are taking that sensor, customizing it to what we need, and putting it into a single file as a single entity. And another pro with this is what happened with the OTA function or with the LD2410 millimeter wave sensor. Both of these were changed and broke the way that it was previously. So we couldn't compile anymore without having to go into it. Now, for the LD2410, it wasn't end of the world because I know I only had 3, so it was very quick. However, when it came to the OTA, having to go and change every file was tedious at best. And then checking that everything works, and yeah, you get the picture. We can achieve going to change one single file. It will change all of our devices, and we can use a one click to just send it to all of them. Also, modularization simplifies troubleshooting. The debugger pinpoints the specific section and file where the error occurs. So we can go straight to that file, we know which line number, and we know why. It streamlines our approach to identify and rectify issues very quickly. Let's see how we can achieve this in the first baby steps. Let's talk a little bit about the value of code standardization. And let me introduce you to what ChatGPT had to say about the subject. By the way, why ChatGPT? Because sometimes I express things in ways that are not always fully understandable, and I thought this was a good way to get something that's understandable and in line with what I was thinking. In fact, I edited it a little bit. Code standardization involves establishing consistent code practices and guidelines within the development of a project, fostering a structured approach to writing and maintaining code. This practice enhances code quality and security and serves as a proactive measure against potential risk associated with inconsistent code styles, miscommunication, and issues slipping through to production. By adhering to an established coding practice, developers create a consistent and high-quality code base, minimizing the chances of introducing common issues and bugs. Overall, the benefit of standardization in software development are clear. By increasing efficiency, consistency, and quality, standardization can help accelerate innovation and improve the overall development process. It provides guidance and support for the software industry, reduces development and testing costs, and ensures better collaboration amongst the development community. So, embracing code standardization is not just about adhering to rules. It's an investment in the longevity and resilience of software systems. Remember, standardized code isn't just about uniformity. It's about building robust, reliable software that stands the test of time. That was a long-winded way of telling you that it has a lot of advantages. And even for us, it has a lot of advantages. And those advantages are when we go back to our code in a year or two, maybe to fix something, we can still read it. We can still understand what's happening. Even if our coding style has evolved, and trust me, a lot of us developers have gone back to code years later and gone, who wrote this stuff, realizing that it was us. I use a lot of code standardization and in what I do. And in this series, we're going to have a lot of that. Again, code standardization might be different for you and for me. So again, take it as a framework. It's something that will help us down the line. It's not now, it's for down the line. So I think I'm going to leave it to that right now. And we are going to move into things that are a bit more exciting. And I'll see you there. Before we dive into any code, it's crucial to first determine what aspects of our project can be modularized and what can't. Once we have the ability to modularize nearly anything, it's important to consider whether or not it's necessary. As Uncle Ben famously stated, with great power comes great responsibility, highlighting the need to approach modularization thoughtfully and responsibly. The key principle to keep in mind is to modularize components that are consistently used across projects, require minimal to no modification. These are entities that we repeatedly copy and paste into each new project. By separating these components into reusable modules, we can streamline our development process and avoid disrupting previous projects that rely on these components. It's also essential to thoroughly test each encapsulated entity with these modular files to address any additional requirement that we would need. For instance, let's take a closer look at the room sensor code to identify components that can be reused in future projects. These are sections that are consistently replicated whenever a new device is created. And let's go into the ESPHome sensors and we'll go to the top of the file. The first thing that comes to mind is obviously ESPHome. This section does not need to be in a file that we keep on copy and pasting to. The next one is the ESP32 component that I will talk about in a later tutorial. But again, why should we repeat it? The logger appears in all of our devices. API, the same. OTA, the same. Wi-Fi, the same. And you can see that these are copy-pastes elements that we can just put into a single file and just reference to that file. The Wi-Fi, the same. Bluetooth is something that I will cover. It's the same, and it's not. We will approach that in a future tutorial. Now, when it comes down to I2C, UART, and one wire, also you could put it into a single file and reuse that file. However, for those, they are dependent on the board and the MCU that is being used. Again, I will address that in a future tutorial. Web server, definitely. There is nothing in there that we change, except maybe that should be 3. By the way, if you haven't tried version 3, I recommend it highly. Status LED. All of the boards of the same type will have the status LED in the same place. Okay, the capacitive touch sensor, no, I'm afraid those, we've entered a lot of the custom sensors. But here, Wi-Fi and uptime, again, these appear everywhere. The SHT40 is custom, but it could be, and I'll show you how to do that, it could be its own component. And at the end of the day, what we can do is bring in all of these components for our project and reduce the time that we use to do these projects through component and through modularization. Look, this is not an exhaustive list by any means, but it's a start. Also, looking ahead, we may anticipate the addition of new entities. I can see, for example, that Thread may have an entity of its own that is very similar to what Wi-Fi is. Meta might be an entity of its own. Zigbee or LoRaWAN may become network entities of their own. And with adopting a modular approach, it will facilitate the seamless integration of these entities by creating a dedicated module to our commons folder. And I will show you that in a minute. But it streamlines the way that we do things. Whilst implementing new entities such as Thread may not be as straightforward as I think it could be, by drawing parallels with existing implementation like Wi-Fi and Bluetooth and the Internet module, it suggests that they'll take a similar path forward. And that would be great because it would make life easy. Now we're going to start talking about what allows us and enables us to do modular components. The first directive that we can use is substitutions. Now, you've seen substitutions before. My ESPHome sensors file has them right at the top, as you can see. And they are very useful. They like global variables. They can be used in any module we want. So we set them once and we forget it and we use it. So this is the first thing that we are going to introduce in our modular system today. Now, I am going to create a file, and I'll talk about that file a little more throughout this tutorial series. So in my ESPHome folder, I will go and click over here, over here, and create a new file. I am going to call this file ESPHome modular to that. Oops. That. Okay. .yaml. Okay. So this is the file that we are going to create. And just to show you, I've done it here on the web server part, but I could have, and I'm going to actually close this. The first thing that you're going to see is that it's available now inside of the ESPHome dashboard. And that is because anything that is in the root of that folder will be available to the ESPHome dashboard. And much like you saw, I didn't put any code in it. If I open it, it is empty. Now, as I said, when we work with modular techniques, we will not open the code in here. So what I will do is go over here, close this one, and as you can see, here is a file and it is empty. I am going to close this section as well. And from here, we're going to start inserting code. And let's start with the substitutions. And I'm going to explain to you exactly what those substitutions global variables are. So here, by the way, we're going to be using a, and if you give me a second, I will pull one out as soon as I find it. I should have took it out earlier, and here it is. For a good part of this tutorial, we'll be using this. This is a ESP 32C3 Mini by Expressive, and I want to thank one of my Patreons and man that you have met in my live stream, Steve, who kindly donated these to me to do tutorials with. Oops, to do tutorials with. So shout out to Steve. Okay, I actually have one that is prepped for these tutorials. I didn't want to show it to you because there is stuff on it right now, and I'm going to have to strip all of that for the future tutorials. Now let's move along. And one thing that I've added to this, and I'm just going to do it now, is I've added something called region, and we will talk about region, I promise. In my case, it's Africa, Johannesburg. Okay, for you, it will be something else. I will, as I say, I will talk about region, why it exists, in a later tutorial where I'll speak about the problems that I faced modularizing, and particularly with the time component. Okay, so let's go through this. Device internal name is something that we are going to use extensively. It cannot have dashes, so it's underscores. The Wi-Fi name is dashes and not underscores, although it works with underscores as well, but it can be dicey. Then the friendly name, obviously, is the friendly name. This is the friendly name, and you'll find it on that it's auto-appended to all of the names. So if you've got a name tag, it auto-appends the friendly name. Then I've got the IP address that I leave up there, and you'll understand why it's there. In fact, it's already there in my room sensor, going to be in another file, and I don't want to modify those files. Then there is the device sampling time, which is generally 30 seconds. I don't see why going any faster at least for us, why going faster would be of any use. And lastly, obviously, the region, which I've just added. Now that I've explained all of these properties, I'm just going to make a note about the device internal name now, and I'll talk about it again later. For me, it's a grouping inside of Home Assistant. So I know that if I have a problem, I can look in the IDs, I can search in the IDs that specific name, and I will find what I'm looking for. Yes, the names can get a little long, and that can cause problems at times. Try to keep your name as short as possible. In fact, you wouldn't call it ESPHome ESP32C3 Mini Expressive, you would call it ESPHome Kitchen. Maybe ESPHome Kitchen Display, but I wouldn't go any further than that. Okay, let's move on to the next section, where I will explain to you the include directive.